Hello, Professor. This is Gautam Kumar Nalluri. I am doing my final semesters in computer science department for my master's degree. So today in this presentation, I am going to explain about a research paper which we have done in cybersecurity course under the Professor VVC. So this topic is completely about the cloud computing and the data security issues which we are facing in this cloud computing. So mainly why we focused on this topic is nowadays the cloud computing is the most popular technology. Like every user is migrating to the cloud because of easy maintenance. So even the number of people are increasing, the number of users are increasing for this cloud. So the data security and breaches are also increasing. So in order to maintenance in order to get like a free safe environment in the cloud computing, we proposed a model here and a application that can easily track the data breaches and data security issues in the cloud computing, which will be very useful for monitoring any data security issues. So which we can further see in this presentation. So coming to the abstract, these cloud services are quickly becoming an integral component of many businesses because of its easily easy maintenance, everything. So despite continuous efforts to build cloud security standards, this is the cloud users to be perplexed about what security productions that could anticipate from cloud services. Based on our findings, we created an ontology that describes cloud security control sets and complements, where we have also created an application that identifies the security dangers that cloud users can use it to get a predetermined the expecting the issues which we are having in the cloud. So the main introduction part is these cloud-based solutions are appealing due to the saving of and easy scaling. Most users are concerned about the privacy and security of the cloud data. So here these cloud security alliances, we have a few companies that already created a few applications. Those are like cloud security alliances, International Organization for Standards, the National Institute of Standards and Technology, and others. Most cloud companies are in a jumbled set of confusion and concerned about what security measures to anticipate from cloud services and what compliance practices to implement for the company data on the cloud. So this paper is mostly examined over 20 security standards in the cloud computing and the IT industries okay, as well. So we also studied the security related white papers on the website for more than 100 cloud providers to examine the security procedures. And also we created a web-based tool that consumers organization may utilize given the dangers that a company confronts. It recommends suitable cloud security policies and supplies that support that support them. So this program categorizes the hazards that cloud users encounters and calculates which security and compliance policy measures must be triggered for each thread. So this tool also shows up the existing cloud providers that support the security requirements, and also there are different steps which we analyze these security threats and possible outcomes and possible solutions we can take in order to be safe in the cloud. So which we will further discuss in this paper. So coming to the ease of use and related about for this one. So the cloud computing interface architecture developed by National Institute of Standards and Technology (NIST) categorizes security and privacy rules as those of the cloud providers. The security compliance models, on the other hand, is applicable to all the roles in the reference design, which we provide in the below. So the IT company model is centered on electronic data processing, network infrastructure, and IT infrastructure. So these IT, in order to organization frequently implement a security controls based on many of these compliance models. So transparency in the cloud service architecture measures and the compliance models will assist customers and end users in achieving dependable cloud data production. So the main we created our own ontology for security control sets and compliance using the web ontology language OWL, which is briefly detailed in the below sections. So in this section, we discussed about main compliance standards and cloud security controls, which we need to which we have referred from NIST and CSC security documents. So if you see here in the security threats and control models, we can see a bunch of threats that are commonly happening over the cloud. So the few of them are listed below. So data encryption, key management, media protection, identification, authentication, and authorization, virtualization, and resource abstraction, portability and interoperability, application security, security risk assessment and management, privacy, electronic discovery and other legal issues, contingency planning, data center operation maintenance, incident response, compliance audit and accountability, awareness and training. So these are the some most commonly existing threats that are going to happen in the cloud. So once the users most aware of these things, and also they handle these things perfectly, so most of those cloud data security issues are gone off. So these threats to cloud computing and how to protect them threats by using security compliance models we will discuss in below here. So most of the security threats are like data breaches, data loss, and account or service traffic hijacking. So these data breaches are confidentiality of data, and eventually the organization which the data is very important. Those data if you gone off, these called the data breaches. So these data encrypted so that even if it is stolen, the attackers cannot decrypt it and cannot see the data properly. So that is one of the prevention method we can take. Even the data loss can happen due to the hardware failure or attacks on the system. Data backup policies should be implemented to overcome this type of threats. And the accounts of services traffic hijacking so affected the confidence and integrity of the users. Hackers can still use a personal data like bank credentials, anti-phishing and fraud detection policies should be implemented to reduce these. So similarly, like that, we have different types of threat types that happen in different security compliance model. So if you see here, we have a table that describes each threat type which will be happening in different security compliance models, which we are shown in the abbreviation here because those are most commonly called with these abbreviation names. So these are the different threat types which we are going to have, which we are going to see in this cloud. Most of them will be data breaches, data loss, and accounts hijacking. So other than that, those rest of them are not frequently happening the data threats. So these are some so other than these things, we have some cloud security and compliance ontology. So here we created a new application by using this ontology web language, which we further discussed here. So this describes the cloud security compliance and its relation with the security control class. So the types of computing cloud security compliance explained in the below session. So each cloud security standard supports a compliance type. The ontology includes the compliance listed in table 1, which we showed below above. The threads and these types detailed in this section are shown here. So this ontology describes the relation between security controls and the security compliance class. So most of these these main classes of the ontology are cloud compliances and also cloud security controls and threats to cloud computing. So cloud security policy recommendation systems, which we most prefer to use every user because they can easily track the errors which we are going to face here. So we have developed an application that can be used by cloud consumers or other people who are going to migrate into the cloud, so that this system helps us users to identify the cloud threats and the security and also compliance models that protect against the threats. So for this application, we analyzed various security compliances, security policy standards, and the threats based on the parameters like description of the security standards, the requirements of the Stanford fulfillment. Web-based applications has been created by using PHP, HTML, Ajax, and web technologies and MySQL databases. So here, this image will be shown clear information about different security models and database architectures for this application. So coming to the application importance, by using this application, cloud consumers can get a list of all the providers who support a compliance standards. So if consumers are not sure the compliance standards to adhere to, they can also search the multiple security controls which they users selects a particular security control, and the system will display recommended security compliance models, and also they provide the in the output model. So this is something we can see as a output if you search for different security compliances. So how do we use this application? The application allows consumers to find security standards for the corresponding security threats. The system also lists the cloud providers that adhere to the standards, which helps users to ensure that the data security on the cloud. So, and also the cloud consumers can also get a list of all security standards supported by the cloud providers selected. So these are some of the screenshots of the existing application. So after this, we can evaluate the adequacy of this model. So CSA is an international organization working with security and other areas of computing. They publish comprehensive analytic reports and guidelines concerning various challenges and shortcomings faced in the cloud computing. So an understanding questionnaire is prepared from the security challenges. That question is how well the issue is addressed and tabulated in the table 2. So here we have raised a few questions that is regarding which topic they are going to address this one. So these table consists of challenges and measures provided. So for example, how unauthorized access of data is being taken care of. So we can use data encryption strength for you solving this challenge. So similarly, we have different challenges that are going to happen in the data in this data security. So each and every problem challenge has some particular method for solving that one. So after this, we have a fairness of the model, evaluating this model. So this is like a validated against actual services, and if the values computed are meaningful and indicated to the trustability of the service. For this purpose, the trust model is evaluated against a few existing cloud service providers. So finally, first and foremost, we would like to express our sincere thanks for this opportunity. And also coming to the conclusion, so cloud computing system security is a large and complex information security manages systems in access control. So in cloud security management and access control, the current lack of relevant research according to the scholars of the study. So we are using experiments designed to simulate inside attack of the cloud environment. And also we have conducted comprehensive study to review the potential threats faced by cloud consumers or the providers who are giving this cloud environment to us, determined and these models and security controls that should be in place to manage the risk. So we used this study to develop a symmetrically rich ontology to model the security threats and control security policies and controls and express the providers data in it. So we have also developed an easy to use cloud security policy recommendations applications for consumers who are planning to move their data to from the local storage to the cloud. So as part of our ongoing work, we are further analyzing other IT comprehensive models that may be applicable in the cloud paradigm and determine if they should be incorporated into our cloud security applications. So we are also developing rules to reason over the ontology to better match comprehensive providers. Finally, thanks for this opportunity, Professor, to explain our research paper in this presentation. Thank you.